you very much for the opportunity to talk to you here today. I hope it's going to be an interesting talk. I was just talking. I heard you had a lot of international talks and global talks, so I guess this talk kind of brings more local issues to mind, hopefully. So without further ado, I want to kind of launch into my talk. I just kind of want to give you a quick overview. So I want to give you a quick overview on the aquatic invasive species, and I should be specific that because on the provincial side, our mandate is the freshwater environment, so I only going to be talking about freshwater aquatic invasives. There are marine invasive species, which I dealt a little bit more when I was working for DFO, but I'm not going to talk about that. So that's a disclaimer. If you want to hear marine talk, I'm afraid, sorry. And then I want to talk how those species are introduced and spread, and give you a bunch of case studies about specific species, how they got here, where they're at, what we're doing about them, and we might be doing prevention, eradication, control, management, or we're not doing anything. And this is obviously the kind of escalating scale of problems you have along there. And then also I'm going to quickly have a kind of a final slide, which just talks about some of the research needs, just to highlight there's a lot of work that needs to be done and can be done on aquatic invasives in BC. So quick overview. A couple of years ago I had a very good intern, and she helped me put together kind of an initial database on aquatic invasive species in BC, and you see the distribution map there. The different colors represent different groups, and we also kind of did like a species summary, and you notice, I mean, why we have, 1 algae, 2 turtles, 3 invertebrates, 5 amphibians. We have certainly 24 fish, so this is a relatively significant number. However, some of those are native to parts of the province, introduced in others, so we still class those as invasive. And we have the plants as the largest column, but here I included a bunch of plants which are not strictly speaking aquatic. However, if they're in a riparian area like the knotweeds, etc., they can have significant impact on the river system, so I added those. So we have a problem in BC. We're certainly not living in paradise here. We'll probably figure that one out. But if you look at kind of south of the border, you immediately feel better about yourself. In many ways, no. So what I did a comparison. There's a very good paper by Sanderson et al. In Bioscience 2009. It's around, I should know the title, but I can't quite remember. It's around the aquatic invasive species, the missing piece in the problems of Pacific salmon recovery, something down the line. And she did a summary for fish species in the Columbia drainage, which naturally in a US paper stops at the 49th parallel, and I lifted that bottom map right out of her paper. And the color grade is, if you can't read it, goes from light to dark. It's 0 to 10 non-indigenous fish species present in the sub-watersheds. Up to 31 to 40 is the dark red, and you see they have watersheds where they have up to 40 non-native species in those Columbia River drainage watersheds. And I kind of did the same for BC above, and you see our worst ones are just about 20 species. And most of our drainage are in the 0 to 10 category, so we're pretty lucky there. If you're interested in salmon recovery in Columbia River, I really recommend that paper. It's a very good overview about how a huge part of the problem has just been completely ignored by funding and policymakers, etc. It's an interesting read. Anyway, so invasive species, meaning species which have been moved past their natural range through human activities. Where have they been found? And there's just a summary of all the species in BC, and not only the fish, so they're mainly in the southern part, and obviously humans move these species, so if you replace the number of species with the number of humans per drainage unit, you see it's almost identical. So it's human who move these things, the more people you have, the more species you have moved to a new area. We kind of know that, but it's kind of interesting how it falls out so similar every time again. And what are the pathways? It's a myriad of pathways. This is a good review, which covers not only aquatic but also terrestrial invasives. But you see, and this is probably by far not complete. It's a ton of pathways. So my job as the kind of aquatic invasive species person, we have to figure out, what are the main pathways, how can we deal with them, etc., etc. So that's a big challenge because there are so many pathways. And now, kind of starting to take you through examples, I show you how we try to deal with particular species or particular pathways. And one thing I've done is once for fish, because for fish we have probably the best data, or we have the best data, how they got in. A lot of other species we don't really know that well. I did a breakdown on what's the most likely introduction pathway, and you could some species have multiple entries there, that's why the number is more than 24, but you see illegal stockings are the biggest pathway. However, it has to be noted that when a bunch of these fish were introduced, like carp was introduced in the early 1900s, it wasn't illegal, obviously. I should probably more call it non-governmental introductions or something. But then authorized stockings is the next one. We have natural dispersal, largely up through the Columbia River, where stuff gets introduced in other systems, because obviously aquatics don't care about, well, no species care about borders. And then we have pet release and aquaculture escape use. So let's try taking you into a couple of individual examples. Is this thing cutting out? Okay, as long as you can hear me. If you don't hear me, start waving or something. So one big example we dealt with recently is the intentional legal introduction was yellow perch and smallmouth bass, and I want to draw your attention here to this area, the Thompson drainage. Yellow dots says the yellow perch occurrences. And just to zoom in, the concern here was this here's Adams Lake, and this here's Shuswap Lake. Adams River sockeye run and Shuswap Lake sockeyes are some of the biggest salmon runs we have in BC. The fish were fortunately just introduced in small lakes around these big lakes, but every lake is connected, so there's a very big concern these fish will spread into these big systems where we can't deal with them anymore, so we have to respond to them right now. And if you look at the previous map as well, we don't have anywhere in the Upper Fraser really these fish species present, so it was another thing where this was really kind of the forefront of an invasion. And some individual, a couple of individuals introduced willy-nilly over like 10, 15 years, we estimate a whole bunch of fish to a number of these lakes. And so what happened, it was a big effort. It was through the use of rotenol, which is a pesticide, meaning kills every fish, everything with gills in a lake. We basically eradicated yellow perch and bass from all these lakes. They're small lakes, and we got rid of them. And unfortunately, this year we just had to do one more treatment for another little lake, but as far as we know, the perch and bass is gone. And I mean, these small lakes obviously took a hit, but even from an ecosystem perspective, you rather do serious damage to a small system to accept widespread damage to a much larger one. So it's kind of, these little lakes had to take the fall out to protect the large systems. Another problem where we have an intentional illegal introduction this is only smallmouth bass, that's in the Beaver Creek, and this is up here, and this is basically drained into the Quesnel, which is obviously Upper Fraser. Here the problem is it's a pretty large, it's a series of large lakes. You have a very thriving bass population, which is, considering where they are, how far north they are, it's surprising that they're doing so well. We have looked at downstream barriers, but they're not successful. There's no way we can really bury them towards downstream. We've buried a few of the upstream lakes, so that at least can't spread further upstream anymore. But the treatment costs, and the cost is not cozy, it's cost actually, sorry, it's around, estimated we are about $5 million, but we just don't have the money right now. So this population problem right now is just sitting there and we don't know what to do with it. But it's a major concern because this is Upper Fraser, and if they can leapfrog from suitable habitat to suitable habitat, the whole Upper Fraser could become a smallmouth bass habitat in the future, which would be really bad. It's not always positive stories, I'm afraid. And one thing, like you mentioned, I just had a grad student completing, and she looked a bit more into smallmouth bass impacts, because despite having this species of bass has been in BC now for over 100 years, we know very little about kind of West Coast specific impacts of this invasive species. Because south of the border, bass, perch, they've been introduced so long, they've been stocked so long that people basically consider them part of the native systems. So they have very little research south of the border into their impacts. So Martina did work into the impacts of smallmouth bass. She particularly focused on 3 lakes on Vancouver Island. She sampled over the seasons to find out what the impacts are, and I just want to take you through some of the key results here. Certainly one part here is she looked in lakes which had smallmouth bass and cutthroat trout. You can see very clearly how the cutthroat trout, where smallmouth bass is present, all they eat is plankton. Very little dragonfly larvae, which are far juicier. And the bass seems to push it out of it. But this was in the same lake, so then she went on and also went into a lake where, one lake where there was cutthroat trout, which is the western lake, the hatched one, and the other one, Cushion Lake on Salt Spring Island, had cutthroat and smallmouth bass, and you see there's no bass present. The cutthroat trout will eat a lot of fish, which is obviously high energy food, and if there's bass present, the cutthroat trout doesn't eat any plankton, and it's all plankton. So there's clearly the bass is able to outcompete cutthroat trout, which is going to impact the population. Another thing is, at least on Vancouver Island, where we have crayfish, big argument by the bass fishermen, because we do have bass fishing clubs, believe it or not, in BC, say, crayfish just eat, smallest bass just eat crayfish. However, we found that while in some lakes on Vancouver Island that's true, in others they don't eat the crayfish. So and if they don't eat the crayfish, they really hammer the fish species again. So, and finally, a little side thing we also did in Osoyoos Lake, we did some spring sampling during the kokanee migration there. And while Martina didn't catch any bass because it was too cold still for bass, and one part of the project was to establish a temperature threshold for bass, she caught a bunch of perch, and they had 85% by energy kokanee fry in their stomach. So this is another reason why, which supports we really have to keep yellow perch out of big systems which have salmon runs in them, because they will just hammer them. And we tried to do some more follow-up sampling with another grant on that. Okay, so just move on to another example. There's also the live food and aquarium trade. Live food is particularly important here in the Lower Mainland, where a lot of species are brought in of fish for the live trade, where just culturally people want live fish rather than frozen one. And the aquarium trade as well is, that's more BC-wide. And the big example there was a Burnaby snakehead. Last year, obviously, was a giant zoo there. The YouTube video was posted in May 2012, and then we had to deal with it. We caught it. But basically what happened there, we had the unique opportunity at least to have dumped it in a pond which had really no good outflow, and the only inflow was basically from a water tap, so we could turn that off, and then we could drain it down, because the city of Burnaby was very great in collaborating with us. And then through all that, we were able to catch that snakehead, and here you see the beast. It's a pretty big snakehead, actually. So we were able to get a small grant, and we worked together with John Moore's lab at SFU. And what we did, here's just a pond. This was a really small pond in Burnaby Park, and he just basically stop netted it, and then just hauled gill nets through it. That's what we call the bugger. But it's just a side note. So first of all, we had to ID the species, and we were able to get some DNA work done with the Harner lab over in Ontario. We were able to figure out that it was actually Channa maculata, which is a tropical snakehead. Because when we saw the footage, everybody thought it was a northern snake, and this is a habitat suitability map from a paper, and you see northern snakehead has a lot of suitable habitat, all of BC is suitable habitat for BC, basically. But now Channa maculata, which is the blotched snakehead, suddenly we're in a total different ballgame. So it's actually, hey, it's a tropical species, hooray. Which is good, because it means it's much lower risk, even if there would have been more, or if this one snakehead would have reproduced or whatever. So that was very good news. The other thing was the John Moore's lab, and they came up with the science here, so don't ask me too many taxing questions on it. They came up with a stable isotope analysis, where they basically looked at the half-life of transition of different tissues, which kind of transition at different speeds from their original state, which is believed either aquaculture food or aquarium food, to that particular pond stable isotopic signature. And basically through that analysis, and you see here, they were able to find some frozen snakehead in the market and some imported one. And they obviously sampled the pond crayfish, and those are the tissues from our snakehead. And based on that, through these different half-lives, they were able to estimate that the snakehead probably was just introduced between 30 and 90 days prior to our capture on the 8th of June. So that again is good news, because we know it hasn't been in there for a long time, so again it reduces the likelihood of any larvae being around or reproduction or anything. So, and we just got it actually accepted in Management of Biological Invasion journals. I know it's not science, but it's good, it's out there, which is important. And the other huge advantage of this whole, you might remember the media frenzy around it, was that gave our ministry the incentive and our ministry to make a commitment, and now we have a whole bunch of freshwater fish species banned in BC, and we went by family level, so there's a pretty long list. The snakeheads are now illegal in BC. Weatherfish is banned. We have the Asian carps, a whole bunch of other ones. Basically all high-risk species you could think of. Within there was a limit on how many species we could list, but those are all listed now in BC, and we're trying to implement a regulation right now. So this is a huge benefit out of this whole thing. And it's illegal to possess, breed them, or transport them, etc., etc. So that, except if you're an accredited zoo aquarium. So this is a huge advantage, because until then in BC, no aquatic species were regulated really, which was a huge legislative gap compared with other jurisdictions around us. Another one I want to talk, the secondary dispersal. So this is now a plant species, but and it's kind of intertidal, so it's kind of on the edge of our mandate there. It's Spartina cordgrass, but this is a very local issue because the main infestation is actually here in the Lower Mainland. There are 4 species of Spartina, and the next slide is probably going to show you the more detail. The problem is they grow intertidally, they can grow much further, and I'll show you actually the next slide right away. The problem here is this is an intertidal map, and the different species of Spartina, the errors are kind of the range in the intertidal they can grow. And the problem is that Spartina can grow much further down the intertidal than anything we have natively occurring. Because Zostera marina, this is your eelgrass bed, and this is basically, we have a couple of native plants here, Salicornia, but in this area here, which are the important mudflats off Roberts Bank, Boundary Bay, which is important nursery ground for your crabs, for your fish, for all the seabirds come on the Pacific Flyway. If you don't deal with Spartina, you end up with something like this, where you just have this monophyletic stance of Spartina out there. And so we know it's a major problem. California, Oregon, Washington, which have the same plants as we have and one extra, they have been running a multi-million eradication program for the last 10 years using herbicides. Plus BC signed on to the West Coast Governance Agreement on Ocean Health, which say we will, together with our southern friends, eradicate Spartina by 2018. So the promise is involved in this, and we're really trying to get on top of it. It's a coast-wide issue, like you can see. These are drift card studies where known occurrences of Spartina with drift cards in the water and see where do they spread. And American ones come up here, ours get down there, all of ours go up north. So unless we all together eradicate it, we will just reinfest each other and the money's wasted. So this is the BC distribution. We have Spartina anglica, and this is your local one here. It's Roberts Bank, Boundary Bay is the big one. We have a bit of patents up in Burrell Inlet, and I think we just discovered a few more. And up in Denman Island area, on Vancouver Island, we also have densiflora. Anglica is the one that we have that grows the furthest down, so this is really the one that is in the intertidal the most. So what has happened so far? Ducks Unlimited has been the lead. They had a large working group, which included a whole bunch of different levels of government, stewardship groups, etc., etc. And they've done mechanical removal since the first discovery of Spartina in 2005. However, you see here they were very good at very detailed measuring how many plants they removed, and you see there's very detailed that, like with the GPS I went around, it's a single plant, it's a clone in this category, there's all GIS map. So they could very exactly map how much they remove every year and what they found the next year. And it became very clear in 2011 that something happened. It's just Spartina is suddenly loving it because the amount of effort stayed relatively constant. Fortunately, around the same time, they put together an eradication plan which said it's going to cost us about $200,000 over 5 years, which is about $1 million, which, you know, out of a lot of people's perspective, $1 million, it's a lot of money. But if you really think, you know, larger, $1 million compared with impacts, it's a lot of time. But so it was thrown out there, and then we started to work with U.S. jurisdiction they are providing us with technical transformation, information, etc., etc. But we also decided in 2010, okay, the manual removal is, we're not getting to less, but it still increases, so let's move to herbicides. So in 2010, the process was started to get federal emergency herbicide registration for 2 products, which they used very successfully in the States. And then that was granted in 2013. And then in April 2013, we went through the provincial pesticides use permit process, which is the provincial process we have to do. Finally got the permit in early August. In late August, we were able to do 2 rounds of treatment, so at least all the Spartina in Roberts Bank is sprayed now. We're doing follow-up monitoring, and the reason why we focus on Roberts Bank is because they did drift cut studies from Roberts Bank and Boundary Bay, and Roberts Bank is really the one that goes up and down the coast. And the question is, so if you remember the timelines, we applied in 2010 for emergency response, emergency registration, and in 2013 we're there, and my timeline is my little squirt here, Dylan, who was, you know, 6 months into it, and it just shows you this is not a feasible way to do a rapid response. You can't wait 3 years. I mean, a plant is one thing, but if the same thing would be a fish or a zebra mussel, we would have a huge problem. So it's one of these things that's broken, we have to figure out how to fix it. Anyway, I mentioned zebra mussels. This is another one, and this is a prevention issue we're dealing with right now. Is zebra and quagga mussels. The big thing, those are freshwater mussels. They have the unique capacity over all our native mussels here that they can attach to solid surfaces using viscous threads, like your marine blue mussels, which you see clinging to the intertidal. And they're a major threat to a whole number of things. I mean, our listed Rocky Mountain Ridge mussel, if zebra quagga mussel would come in, that would be the end of that. A lot of people probably wouldn't care about that. However, this mussel also will clog any intake pipe of a hydro dam, municipal water supply, agricultural water intake. And that's not hypothetical impact, but this is shown impact in the Great Lakes. We know they do that. So we had some end-of-year money last year, and we did a Ministry of Environment commissioned a contractor to do an economic impact assessment, and they estimated that just the impact on BC hydropower and water supply per year would be around $9.2 million, and impact to boaters would be around $12.4 million a year. And what the impact to boaters would be, you can see very nicely over here. If you leave your boat in a zebra-infested lake, depending on the time, it looks like this, and it needs major work. Because we really like cooling systems where water runs through really fast, and they're very good at clogging that, so that would be really bad. And I also have to say, I mean, maybe some of you have seen biologists doing economy out there, and they come up with crazy numbers, and if you look at the economy behind, it's a bit dodgy. This is a very conservative estimate. For example, we didn't have the data to estimate impact on commercial fisheries or anything like this. So the real number is likely to be multitude higher, but this was what we had data for, so that's what we put in there. The other thing is, on the upside, BC is part of the Columbia River Zebra and Quagga Mussel Rapid Response Plan, so all the Columbia River Basin jurisdiction are trying to work together. That's us, Washington, Oregon, Montana, and Idaho. And we also started more and more monitoring since 2011 in BC. So how do they spread? The key pathway there is recreational boats, meaning boats that are used in one lake, they go on the trailer, they go to the next lake. And the way they can do it, because as I mentioned, they can attach to boats, so they can attach to the hull. When they settle, they're very small, you're talking 2-3 millimeters, so they're very hard to notice. They also have free-swimming larvae, which survives a month in water. So this is microscopic larvae, so not only attached mussels on the boat can be a problem, but you can get like a life well, or some wakeboards have ballast tanks nowadays. Water in there can also spread them around. And every year we get a whole bunch of boats which are kindly intercepted by our southern neighbors, where they give me a call, and we then deal with these boats, because they are destined for BC and they have mussels on them. So it's again a real threat. And the distribution of BC in North America of zebra and quagga mussel is basically, they got introduced in the Great Lakes in the early 80s, and then they've spread ever since. And unfortunately, you might not have heard of it. As of 3 weeks ago, there have been several locations in Lake Winnipeg where they've been found. So they just jumped into the prairies. So that's really bad news for us. So we're really trying to get on top of that issue. There has been a risk assessment was done. It was Department of Fisheries and Oceans together with the provinces. And we just looked, could they survive here? And they certainly could. The high red color means it's very suitable environment. If you look, this is like your Kootenays, Okanagan area, very high calcium level, zebra mussel would just be happy and jolly. This here is still pretty suitable. This area might not be suitable. So maybe small parts of the province would be protected from it, but basically we have most international boats going in this area, and this will be very suitable. However, as part of this big legislation, which I mentioned before around the snakehead, we were also able to slip in zebra and quagga mussels. So now zebra and quagga mussels are prohibited in BC now as well, and those are prohibited alive or dead. Alive or dead because there's really no reliable field method out there that enforcement staff could test if a mussel is dead or alive on a boat. Because imagine a 2 millimeter big mussel hanging onto a corner of a boat. How can you tell it's alive or dead? You're not going to find a heartbeat or anything. So other jurisdictions have done just alive, and it's been a huge nightmare around lawsuits, etc. So we just say alive or dead. Never mind. And we are trying to implement that right now as well, which is a huge step forward. Because in the past, when I got a call from the States, boat is going to Nanaimo, boat is going to Vancouver, boat is going to Kelowna, suspected mussels on it. All I could do is call the guy up, and it's always been a guy so far, and ask him nicely, And it worked every time, but the one day someone could have told me to just, I could have said, okay, that's the end of it. And now we actually have legislation in place that could really stop this. And given the potential impacts, it's very useful that we have that information. Other things, just on the management side, I mentioned we work with the Columbia River Basin team. There's a jurisdiction. One thing is there's a lot of monitoring happening south of the border, and this is just off the website, and you can just see, well, okay, BC, we are starting the monitoring. We have a couple of big reservoirs we've been doing now for a couple of years, but there's a ton of it happening south of the border, and that really helps us to reassure that the Columbia River is still kind of clean of mussels. And I forgot to highlight that the reason why they're putting so much money and effort in keeping them out of the Columbia River Basin, if you remember to the map here, in the lower 48, the Columbia River Basin is pretty much the last major watershed which doesn't have these mussels in it. And of course they have a ton of hydro dams on there. So while our cost estimate is 20 million a year, theirs is in the order of 60, 70, 80 million a year because they have so many hydro dams there and they would have to retrofit them all. It would be a huge nightmare for them. Plus, sand recovery, wave goodbye to that. So the other thing I wanted to talk about is just again on the political side, is through working with other jurisdictions and kind of what the gold standard is for prevention of aquatic invasive species and particularly Seaborne quagga mussels. The two programs that Idaho and Montana are running now, those are financed by boat stickers or boat licensing fee. And what you see, Idaho, this is a highway map of Idaho, and all the red dots are inspection stations, so they basically inspect pretty much every boat that comes into their state. So they do 100,000 watercraft inspections since 2009. Per year it's about 10, 20,000. They are intercepting a small number of boat onlys, and you think, why is it worth, inspecting so many boats if you have such a small success rate? You have to also realize that every boat you inspect, and as long as you make it a pleasant experience for that person, it's also a huge outreach opportunity. You can give them a leaflet, you can tell them about the risk, and while the program is mainly focused around Seaborne quagga mussel, the beauty of this boat inspection program and pushing this message associated with it around clean, drain, and dry is that with that approach you prevent all sorts of aquatic invasive species spreading, because recreational boats spread a ton of invasive species. There's the mussels, there's the New Zealand mud snail, there's a whole bunch of planktonic invasive species in the Great Lakes which we don't want. There's Eurasian water milfoil. And as long as you get boaters educated and make sure they clean, drain, and dry their boats, and you can do that through these programs and other means, of course, they won't spread any of these we know about, but also the ones that might come down the line. So there's a good advantage of having a program which is kind of targeting a vector rather than a species, because that vector will persist even when that species might not be an issue anymore, or there's a worse one coming along. And one other thing, sorry, I'm digressing a little bit, but I got time. So. The other thing we found out, which was really interesting through those inspection programs, is a little bar chart on here. You probably can't read it, but this is a commercial versus non-commercially hauled boats. Meaning, non-commercial is your average Joe towing his boat on his trailer. Commercial is a big boat bought by someone on a big truck being driven somewhere for money. And while there's only a few hundred of these commercial transports every year versus tens of thousands of boats and trailers, if you compare the absolute number of fouled boats in the blues commercial versus non-commercial, it's actually almost higher in the commercial one. So we discovered there's a low frequency, high risk pathway versus the recreational one, which is high frequency, kind of small amount of risk pathway. So in the south of the border, they've started to work more and more also with these commercial haulers, because unfortunately in the current economic climate, it's very cheap to buy a boat in the US. So a lot of Canadians buy boats in the US, and like you saw on the map, most of the US is Seaborne mussel positive or quagga mussel positive. And then it's short on a truck, it gets shipped up here, and then sometimes they go on the lake pretty quick. So this is a major. Most of the boats that I deal with are actually boats that have been bought south of the border. Okay. So just as a last slide, I mean, since I'm at UBC here, I thought I'd also just throw out there, and you probably gathered it already, there's a huge amount of research which we need, which isn't done. There's a lot of work which would help us hugely in more effective management and understanding of aquatic invasive species. And I just put a watchlet there together. That was just a brainstorming. For example, we do all these road node treatments, or we did a couple, and we probably have to do more in the future. but we know very little about what it does to the aquatic inverts and how they recover, which is obviously very important for the food web. We don't know, one thing is, what would happen if those seabed quagga masses get into our large lakes and reservoirs? What would happen to the food web? There's a lot of very good data from out east, but it would be great to apply this to BC data. And then there's also a bigger thing, the decision making around eradicate, control, manage, because you've seen this huge number of species we have, which are in a lot of places. Where do you spend your money best? Because I've highlighted like 5 or 6 species, but you saw, we have like 24 fish species alone. So where do we spend our money best? The moment those decisions are made, but there's probably a more effective way of doing that, and it would be cool to find out better ways of it. Then there's just the good old box standard habitat suitability and dispersal modeling you could do around, which species is likely to spread where, how much of a risk are they? Because there's so many species which are in some pathway, and we just don't know where they could survive in BC. And that would be very important to determine what risk level they pose. Remember the snakehead maps. If it's a tropical snakehead, I really don't care too much, because maybe it carries a disease, but otherwise if you throw it in a lake here next winter, it's gone. But if it's a cold water snakehead, then I do care very much about it, because if it gets in the freezer and starts spreading, then all hell breaks loose. So that's important. Then obviously there's the whole thing of climate change. Can they start spreading? A lot of the invasive fish we have are warm water fish, so if it gets warmer, how much further could they spread? The big one is also environmental DNA, which has been thrown around for all sorts of things, but invasive species and of course threatened or at-risk species are the perfect candidate for that, because these are species where you really want to know if there's 1 or 2 in a lake, versus for a lot of other things, at that level it's ecologically irrelevant, but for invasives it would be a monitoring tool, but also once you do a treatment in a lake, it would be a very good way to find out if you actually got them all, if you have to retreat. And then there's a whole bunch of impact and distribution studies of aquatic invasive species where we have something somewhere we don't really know what it does or how far it's really spread. And for example, we have weather loach in the Alouette system. We know it's there for at least 8 years now, but we haven't had the time or money to do any sort of distribution study. How many are there? Where are they? How are they doing? We don't know. And then there's also a whole social component where, because these species are spread by humans, there's a whole kind of human behavior component there. Why do people spread them? Where do they spread them? And if you understand that better, you can also manage it more effectively and reduce the risk more effectively, because you get the targeted outreach, you know which areas to focus on, which groups in society, etc., etc. And I probably could think about more if I would have more time, but that's probably. We'll leave some time for questions. So here's time for questions, my contact details and stuff. So.
Thank you so much.
Thank you.